Hello viewers, welcome to Elisam Academic. So today we'll be looking at a predicted Waec question for 2026. Waec practical question for 2026. This is very important. So this is a predicted question that you will likely see in this year Waec chemistry practical. The question says A is 0.103 mole per dm H2SO4. B is a solution containing X gram per dm cube of sodium hydroxide. Put A into the burette and titrate it against 25.0 cm cube portion of B using methyl orange as indicator. Record the volume of your pipette. Tabulate your burette readings, and calculate the average volume of A used. From your results and information provided above, calculate I amount of H2SO4 in the average volume of A used. II concentration of B in mole per dm cube. III value of X. Remember, value of X. Equation of reaction. This is the equation of reaction H2SO4. Yes, and then this is the question. All right. Now, for this question, I'll be using the theoretical value for the volume of acid. The theoretical value based on the Waec instruction for 2026. We notice that the theoretical value, that is VA, is given to be 12.14 cm cube, like theoretically from the specimen from the instruction manual, that we have your relative density of 1.84, and then your specific your percentage purity of 98, your volume of acid, which is 5.6 cm cube. Do you understand? So with this you can get your theoretical value. You first get your concentration of acid, you get your concentration of B, and then you use it to get your average value, which is this. Are we together now? So let's just suppose we'll be using this value, that is your theoretical value for A, for your acid, that's your VA, as our volume of acid. And remember, our VB is already given in the question. It's already given in the question, which is 25.0 cm cube. It can be 20.0 cm cube depending on the pipette you are using. Do you understand? Good. All right. Now, the first question we are asked to calculate is the what? Is the amount of H2SO4 in the average volume of A used. In the average volume of A used. This is very important. This line is very important, and you need to pay careful attention here. Now, after our the titration, let's assume in your exam, you've done your titration and you've gotten your VA to be 12. It must not be exactly 12.14. Do you understand? This is just the theoretical value based on the information that are in the instruction. So, but after your titration during your exam, you can get your VA can be 12 point whatever 30, 12 point whatever. Do you understand? Which is not really far. Are we together? So it must not be exactly the same thing. So after you must have gotten this, then you now start solving, and the first thing you have to calculate is the amount of H2SO4 in the average volume of A used. Now, you should know that when you are calculating for amount, there is what we know as mole. No, that is mole, which is the amount in mole, right? Equals to mass over what? Over molar mass. Over molar mass. This is one important formula that you must know. But even if you look at this formula, we can't use this formula to solve this kind of question, because the mass is not given. Instead, we were given the concentration of the acid. Instead. Had it been mass was given here, we could use this formula. Do you understand? Then we already know the molar mass. We can calculate the molar mass of acid from here. So, but because mass is not given, it's concentration. So we use the second formula now. Which is the amount in moles equals to what? Concentration. Let me just use conc in what? In mole per dm cube. Multiplied by volume. volume in cm cube divided by what? Divided by molar mass. Divided by molar mass. Please, anytime you are using volume in cm cube, sorry. Divided by 1000, not molar mass. Divided by 1000. Divided by 1000. So now, whenever you are using volume in cm cube, you must divide by 1000. But whenever you are using your volume in dm cube, so you don't need to divide by 1000. This is very important. But if you look at this place, they said amount of H2SO4 in the average volume of A used. This is the average volume of A used. That's the one you after your titration, that is the one you got. Do you understand? So this is the volume of A used, average volume of A used. Your first titer, second titer, your third titer, or the average of, if it is first and second, you use. If it is second and third, when you add them together, you divide by 2. And if you use 3, if you use first titer, second titer, third titer, you divide by 3. So your average volume now of A is this one now. So they are now asking you to calculate the amount of what? H2SO4, which is your acid, in the average volume of A used. Do you understand? And the average volume of A used is given to be in cm cube. So that means that your volume here is what? Is cm cube, and that is why you have to divide by 1000. Divide by 1000. So what will be our amount in mole now? So equals to our conc here, concentration in mole per dm cube of A. Look at it here. So we have 0.103 multiplied by what is the average volume of A used. Now sometimes they can say amount of H2SO4 in 23 cm cube, or they can decide to give you the value here, like volume here by themselves. But if they did not give you, they will say in average volume of A. So that means you are going to use the volume of what? Of the average, as that's the average volume of acid that is used. So multiply by 12.14 divided by 1000. 1.25 divided by 1000, which is going to give you 0.00125 moles. Yeah, so this is the amount. This is the amount of what? Of H2SO4 in the what? In the average volume of A used. Remember, I said if you are giving a value here, let's say you are giving 23, you are giving 12, you are giving any value here, you will use the value as this place. If it is given as dm cube and cm cube, you will divide over 100. But if it is given in dm cube, you don't need to divide by 1000. That is very important. All right. So this is the amount of what? Of A in what? In the average volume of the amount of H2SO4 in the average volume of A used. Now the second one is concentration of B in mole per dm cube. Concentration of B in mole per dm cube. And if you look closely, you notice that the value that is given here is X. That is, they did not give us any value here. They gave only X. Now, for you to get the concentration of B in mole per dm cube, for you to get the concentration of B in mole per dm cube, this is in gram per dm cube, right? This is in gram per dm cube. So for you to get the concentration of B in mole per dm cube, you will use the formula that we all know. Good. So this is the concentration of A in mole per dm cube. This is the concentration. This is the volume of A in cm cube. This is the concentration of B in mole per dm cube, which is the one we are looking for, right? Then this is the volume of B, which is the volume of pipette that we use. All right. So now here, this is the what? The number of mole of acid. If you look at the equation of reaction, we have the number of mole of acid here is 1. While this one is the number of mole of base, which is what? Which is 2. Are we together? So we have. So to calculate this now, we have concentration of A now is given in the question, which is to be 0.103 multiplied by what is the volume of A? What is 1? That's 12.14 divided by CB. That is what you are looking for. Multiplied by the volume of B. That's the volume of base. 25 cm cube. 25 cm cube equals to the number of mole of acid here is 1. Reach over number of mole of base, which is what? 2. So when you cross multiply, you have CB equals to 0.103 multiplied by 12.14 multiplied by 2, all divided by 25 multiplied by 1. equals 0.100 mole per dm cube. This is the concentration of what? Of B in mole per dm cube. Now the third question is now value of X. The value of X here. The value of X here. So now, since we've gotten, remember the value of X is for the base, that is the B. And we've gotten, and when you see gram per dm cube, there is a link. There is a formula that links gram per dm cube with what? With mole per dm cube. And that is given to the what? Concentration in mole per dm cube equals to concentration in gram per dm cube over what? Over molar mass. And what is the molar mass for base? That is for NaOH. Sodium is 23 plus oxygen is 16 plus hydrogen is 1, which gives me 40 gram per mole, which is my molar mass for what? For base. And remember the concentration of base in mole per dm cube, I've already calculated it. So what I will do is I will impute this one here. So I will have 0.100 equals to concentration in gram per dm cube, that is gram per dm cube, which is what I'm looking for, the value of X now here. So divided by what is my molar mass? 40. So if you cross multiply, so gram per dm cube, sorry, if I put the gram per dm cube equals to 40 multiplied by 0.10. 10 is going to be 4.0 gram per dm cube, which is my value for what? For X. So this is my third one. I. Good. So this is how to solve this kind of question. In case you see it in your Waec, this is how to solve it. Thank you. Make sure you subscribe to this. If this is your first time, subscribe to this YouTube channel and then share with your friend. Thank you.